Somewhere in our galaxy, a countdown is approaching zero. And surprisingly, right now, astronomers are staring at an empty patch of sky. So what are they looking at? Not a star. Not a planet. Not a black hole. Nothing. Just a tiny piece of darkness. And yet some of the most powerful telescopes on Earth keep checking it. Night after night. Year after year. But why? Because somewhere in our galaxy, a countdown is approaching zero. Nobody can see it. Nobody can hear it. But scientists believe that empty patch of sky is about to do something impossible. It may suddenly contain a star. Not next year. Not someday. Possibly any night now. Yes, any night. Soon. A bright new star. Visible to millions of people around Earth. And nobody knows exactly when it's going to happen. Not NASA. Not the world's biggest observatories. Nobody. All they know is that something appears to be reaching the end of a countdown that has been running for decades. Now, if this happened in a science fiction movie, people would call it an alien signal. A gateway opening. A message from another civilization. Because stars are not supposed to appear overnight. The universe doesn't just add new lights without warning. But that's exactly what may be about to happen. And the strangest part? The event we're waiting for may have already happened. 3,000 years ago. Which means humanity isn't waiting for an explosion to happen. Rather, humanity is waiting for an explosion to arrive. Right now, at this exact moment, a flash of light may be racing toward Earth. A flash that began its journey before empires rose, before nations existed, before anyone knew what the stars actually were. For 3,000 years, it has been crossing the darkness between worlds. And now, it may finally be reaching us. The weirdest part? This isn't the first time humanity has waited for this event. In fact, the entire world thought it was about to happen in 2024. News channels covered it. Astronomy websites covered it. Social media exploded with excitement. People were told to watch the sky. Then, nothing happened. No explosion. No new star. No cosmic fireworks. The prediction appeared completely wrong. People moved on. The internet forgot. Case closed. Except it wasn't, because the prediction wasn't wrong. Only the timing was a little wrong. The countdown never stopped. And recently, astronomers began seeing something they had been waiting years to see again. A fingerprint. A warning sign. The exact same warning sign that appeared before the last eruption. Suddenly, the countdown was back. And that's why scientists around the world have started staring at that same empty patch of sky once again. So what exactly is hiding there? To answer that, we need to travel nearly 3,000 light-years from Earth. To one of the strangest systems in our galaxy. Astronomers call it T Coronae Borealis. But honestly, the time bomb might be a better name, because this system spends decades preparing for an explosion, then detonates in a matter of hours. At first glance, it looks like a single star. In reality, it's two stars locked together in one of the most dangerous relationships in the universe. One star is dying, the other is already dead. And somehow, the dead one is winning. The first star is a red giant, an aging star slowly running out of fuel. The second is a white dwarf, the collapsed core of a dead sun. Imagine compressing nearly the mass of our sun into a sphere only slightly larger than Earth. The result is gravity so powerful that it can steal matter from a neighboring star. And that's exactly what's happening. The dead star is feeding. Hydrogen gas streams away from the red giant and spirals toward the white dwarf. Day after day, year after year, decade after decade. Imagine discovering a corpse that feeds on the living. That's essentially what's happening here. A dead star feeding on a dying one, gathering fuel, building pressure, preparing for detonation, like an ancient machine following instructions written into the laws of physics themselves. Eventually, the stolen hydrogen forms a layer across the white dwarf's surface. Pressure builds. Temperatures climb into the millions of degrees. The system becomes a ticking cosmic bomb. Then everything reaches a critical threshold. The hydrogen ignites. A runaway thermonuclear reaction races across the surface. And in a matter of moments, the entire system erupts. Its brightness increases thousands of times over. A previously invisible object suddenly becomes visible to the naked eye. Astronomers call this a nova. Unlike a supernova, the star survives. The explosion ends. The system resets. And the countdown begins all over again. But here's the question everyone wants answered. What will this actually look like? The answer is surprisingly unsettling. Nothing dramatic. No giant fireball. No shockwave. No Hollywood explosion. Instead, everything looks normal. The constellations appear exactly where they should be. The sky feels ordinary. Then you notice something impossible. A star that wasn't there before. Not yesterday. Not last week. Not for decades. The universe appears to have edited itself overnight. For a few brief nights, millions of people around the world will be able to see it. No telescope. No observatory. No special equipment. Just their own eyes. Imagine standing outside and realizing you're looking at an explosion that happened 3,000 years ago. Then just as suddenly as it arrived, it begins to disappear. The new star fades, night after night, until eventually the sky returns to normal, and the visitor vanishes back into darkness. But here's the truly fascinating part. This isn't the first time humanity has received this message. The last confirmed eruption happened in 1946. World War II had just ended. Humanity was entering the atomic age. Then one night, the sky changed. A new star appeared. For several nights it remained visible. Then it faded away. Gone. Historical records suggest similar eruptions happened in 1866, and perhaps even in 1217. Different centuries, different civilizations, different people looking up at the same sky. Yet all of them may have witnessed the exact same message arriving from deep space. The same star, the same eruption, the same cosmic clock, which brings us back to the fingerprint. Before the 1946 eruption, astronomers noticed something unusual. The system suddenly became dimmer. A strange drop in brightness appeared before the explosion. Scientists call this a pre-eruption dip. At the time, nobody knew what it meant. Only later did researchers realize they had been looking at a warning signal. And recently, the time bomb began showing the same behavior again. The same dimming, the same pattern, the same fingerprint. Researchers compared modern observations with historical records, updated their models, recalculated their timelines. And while nobody can predict the exact night, one conclusion became impossible to ignore. The eruption window remains open. The countdown is still running, which means the next flash of light reaching Earth could arrive at any time. So here's how to find it. Locate the Big Dipper. Follow the curve of its handle until you reach the bright orange star Arcturus. Then continue toward Vega. Between those two stars sits a small horseshoe-shaped constellation called Coronae Borealis, the northern crown. Focus on the left side of that crown. Right now, you'll see nothing, just an empty patch of darkness. But remember it, because that empty patch of sky may not stay empty for long, and when it finally changes, you won't be watching an explosion happen, you'll be watching an explosion arrive. A message that has spent 3,000 years crossing the galaxy, a message that may finally be reaching Earth, and when it does, the night sky itself will change. Until next time, subscribe the Escape Edit and keep looking up.